Let's get into line design. Now we looked at a station design and how can we now leverage that by building these stations next to each other in a sequential fashion like here, which basically look at the entire build of how the line is going to be for the entire chassis. The brake caliper installation was only done on one station, station 40 in this line, and now how the line can be looking at in a three-dimensional fashion. Now, having this virtual model feeds into or is capable of feeding into a full line level simulation. And when we get into a line level simulation, now we can understand and create scenarios where we can run actual production schedules. The production schedules can be of different axle types, of different volume run through it. So let's look at an opportunity, an instance over here where we have 40 of axle A, 20 of axle B, and 40 of axle C, and run the simulations of how our production is going to look like. We can have a dynamic monitoring of how much axle A and B and C are produced. And the right side gives the throughput for the day. And our target of the throughput was 500, and we're able to achieve a little over 500. So that kind of a combination is good. But let's change the combination now to a new combination where we just need 10 of axle A, 20 of axle B, and change axle T's volume of 70 because of the demand that is done, and run this production schedule as a simulation and then understand what it's doing to productivity. Is our line set up to do really maximize the utilization of resources, our manpower? And when we look at it, there's some dips as it goes along, and our end throughput for the day is way less than 500, which was our target at around 417. And this basically tells us that there's some bottleneck situations that's happening ahead of time, even before this production schedule can be run. Now, this can be expanded to the entire plant, where the axle is feeding into the tractor, and how the entire plant production and tractor production is affected by this bottleneck situation that's happening on the axle line. And this also provides us a good look into the worker utilization as to where they are going, where their time is effectively utilized and not where effectively utilized. As you can see, several of the workers that are downstream in this process are waiting for several things, waiting for the job to come to them, or walking to the job, or waiting for something else, for materials and such. So if we have this level of visibility upfront in designing any of changes in there, then we can minimize how the impact is going to be. And that ends up into improving our efficiency, improving our throughput, and maximizing our capacity utilization, and hence giving a higher level of OEE and production attainment. And also, this helps us to keep the right amount of inventory on the shop floor so that we do not have inventory lying around based on the production schedule that they're waiting for 2 days in a row and not being consumed, so that we have the right product on the floor for the right consumption.
Thank you for watching. To learn more about this topic, check out the links in the description. And if you enjoyed what you saw, like the video and subscribe to the channel.